Okay, so this is Chapter 8 continued. So let's go ahead and work through some hypothesis tests. We're working through our steps, and our steps are to determine the hypotheses, then we look for the test value, the critical value, state our decision, and conclusion. You'll get really comfortable with those in just a minute. So this one says that a real estate agent believes that the average closing cost of a home is $6,500. She selects 40 home sales, that's N, at random, and finds that the average closing cost is $6,572. So this would be X bar or M. The standard deviation of the population is 338. Test her belief at alpha equals 0.05. So she believes that the closing cost just simply is $6,500. Is this over the purchase price? So that's not what we're looking for. So let's go ahead and state our hypotheses. So step 1, hypotheses. We need that null hypothesis, which is, let's see, we're testing an average, so that would be mu. The null hypothesis is always the equal sign. And in this case, she believes it's 6,500. We don't use the 6,572 because that's the sample. So 6,500. And then our alternative, H1 or H sub A, is mu. Let's see. She believes it's 6,500. She selects 40. There's nothing that says she thinks it's greater than or less than. So it either is or it isn't. So that would be the not equals. Remember, your choices are not equals, less than, greater than. So not equals 6,500. This is called a two-tail test. Okay, step number 2. This time for step number 2, let's do the critical value next. So for the critical value, I'm going to draw the normal curve. So for the normal curve, I know that 6,500 is right here in the middle. That's mu. If I do it in terms of z-scores, 6,500 has a z-score of 0. It's 0 away from the mean. But I'm saying that it's not equal. Not equal means it could be significantly less than, or it could be significantly more than. But my total rejection region is 0.05. So that really means that this is half of 0.05, 0.025, and this region's area is the other half, another 0.025. So we're looking for these critical z-scores. I need the z-score that cuts off the lower region and the z-score that cuts off the upper region. Well, the nice thing about our z-scores is that everything's symmetric. If 0's in the middle, this is going to be negative. That'll be the same number but positive. We're going to use, again, table F. We can do the rest in the calculator. So we want table F. I grab my book, or you've got maybe your table F printed out from the document online. Let's see. I need to know that I have 2 tails this time, and alpha is 0.05. So now I'm going to use 2 tails. 2 tails, alpha is 0.05. That puts me in the middle column. I look all the way down. We're not using t-scores. We're using z-scores. And I go all the way down, and I find that my cutoff, I know you can't read that, but on yours, you can read 1.96. There's no negatives in this table, but you can use the fact, here it is, that you've got the negative and the positive of the same value. So 1.96 plus and minus off of table F. So my critical values are negative 1.96 and positive 1.96. And you can write that as plus or minus 1.96. Okay, now to review from before, this would be my fail to reject region. So that would be where I fail to reject the null hypothesis. Anything in my outer tails is my rejection region. So reject the null hypothesis if I land here or if I land over here. Okay, so there's the critical value. Step number 3, I need the test value, and I'm going to use the calculator. Because I can. Your book Here's the formula sheet. It has some really great formulas. That's chapter 7. For chapter 8, they're here. You can use the formulas. You'll get the same values that we get off the calculator, but I'm going to use the calculator. It's just so much easier. So for the calculator, though, I need to know what my values are. I need the sample mean, which is 6572. I need the hypothesized mean, which is 6500. I need the standard deviation. I'm reading up above all the things we had labeled. I need the standard deviation, which was 338. Standard deviation is 338. And then we stated that there were 40 homes, n equals 40. Alpha is 0.05. So we're looking to see what the z-score is for 6572. I know it's over here somewhere. I want to know if it's going to be in the fail to reject region or in the rejection region. I'm going to use both calculators to type this in, so I'm going to type this in twice. So here I am. I'm going to go to stat, tests. I use the first test. I don't have data. That would be like individual home values, and I don't have that. So I actually have a mu, which is 6,500. My standard deviation was 338. The sample mean was 6,572. I had 40 as my sample size. And my alternative hypothesis is not equals. So alternative hypothesis, I hit enter to choose that is not equals, down, and then enter to calculate. And the calculator gives me my test z-score, 1.34. So my test z-score is 1.34. This is the z-score for 6572 is 1.347. So I've got steps 1 through 3 done, and I'm ready for step 4, which is my decision. So step number 4, decision. You can mix 2 and 3 up, those steps. The order isn't important, but your decision is always next. So if I take a look at my test value and my normal curve here, which is getting messy in a hurry, my cutoffs were at 1.96. I found that 6572 was at 1.34. So it was at 1.34. That's where 6572 lives. I didn't make it into the rejection region. I'm in the fail to reject region. My z-score wasn't big enough. So my decision is to fail to reject the null hypothesis. It's that simple. I just read it off of my chart here. I either fail to reject if I'm in the middle, or if I reject if I'm in a tail. Well, what does that mean? Step number 5, conclusion. This is the most important step in my mind. What does that mean? The question said to test her belief. Is she right? Well, what did she believe? She believed that the average closing cost is 6,500. And you know what? We couldn't reject it. The number that we found, that 6572, was not significantly more. It fell in the fail to reject region. It fell in the fail to reject region. It was not significantly more. So we're going to conclude that she's right. We're going to fail to reject. This is like the court system. We never say we accept it. Just like we never say, we say either guilty or not guilty. A verdict would never be innocent. It's either guilty or not guilty. We either reject or we fail to reject. That language is important because we don't really know if it's true. We're just drawing a conclusion based on our sample. So she seems to be correct. So she seems to be correct. The average, I'm going to abbreviate, but you shouldn't on your exam, closing costs. So closing costs are $6,500. We couldn't find a significant difference. I want to state one more thing about, we talked about those rejection regions. I'm going to give you an example of a two-tail test here again. It all boils down to, we had fail to reject, right? So this is fail to reject. To reject. And then reject is in our tails. Reject, reject. But there's another way to think of this, and it works so well when you're doing your conclusion. The sample, it's either not significantly different, so here there's no significant difference. I love this because it works for everything we're going to do. There's no significant difference if you're in the middle. And if you're here, you did find that it was significantly less. And here would be significantly, I'm going to abbreviate, more. And when I'm saying less and more, I mean compared to mu from our null hypothesis. So no significant difference in the middle, but you are finding a significant difference, significantly more in the right tail or significantly less in the left tail. Okay, let's get another example in. Let's do, what else do I have here? Oh, this one's a t-test. Let's do that one. This is a good one, actually. Oh, and you know what? Before I do, I promised you one more thing. I promised I would use the other calculator that has a slightly different operating system to do the test value. So let's redo that test value really quickly in this last example. Let me clear here. So I'm going to go to stat, tests. It all is very similar. But now it just gives me a title, so that's a tiny bit different. And the order here is a little bit different. I'm not using data, I'm using pre-computed statistics. They gave me an average, not the raw data. So I go to stats. The null hypothesis, that mean was 6,500. The standard deviation, so it's a slightly different order, was 338. Sample mean was 6572. There were 40 in our sample. Two-tail test, so I hit enter on the not equal and then calculate. So it gave me that same value, 1.347. So just a slightly different look for the other operating system. Okay, so now let's do that next example. Okay, so here's the next one. Let's do the, this one, the title on the page is t-test of the mean. So a travel agent claims that the average of the number of rooms in hotels in a large city is 500. Okay, so did you catch that? The average is 500, mu equals 500. Gosh, doesn't that look like a null hypothesis? At 0.01, is the claim realistic? It doesn't say is it big or is it small. It says realistic. Is it true or not true? So right off the bat, I've got my hypotheses, step one. Mu, it either is 500 or it is not. So not equals 500. So there are my hypotheses. This time it gives me data, and it gives me a small amount of data too. So I'm going to go ahead and put my data into my calculator. I'm going to actually use the calculator I was just using, I think is this one. Let me see. So here's the one I was just using. So I'm going to put my data into my calculator. So I'm going to go to, so I'm going to turn it on, and I'm going to go to Stat and Edit, and let's put our data into L1. I'm going to actually hit Clear and then Enter to clear that list, and I'm going to type this in 713, 300, 292, 311, 598, 401, 618. I'm going to quit. I don't need to compute one variable stats. I could and write it down and do it that way. I could go calc one variable stats. My list is in L1. I leave the frequency list alone and I hit calculate. I could do that, but the calculator will do it for me. So I'm going to quit this. I am going to go to stat here in a minute, but I want my data in there when I'm ready for that. That was the critical value, right? When I'm ready for, no, the test value, I'll grab my calculator again. Okay, so step number 2. Step number 2, we need the critical value. Critical value. Let's see, alpha is 0.01. If I just sketch myself a quick curve here, I have a teeny tiny little rejection area, but it's not equal, so it's split between both the left and the right. So this is a two-tail test. Anytime you have the not equals, it's two tails, because it could be less than or more than. Anytime you have the greater than or just the less than, it's two tail. So I need table F again, so let me grab table F. In table F, you'll notice that this is the t-distribution. And the z-scores that we've been using are at the very bottom, where my degrees of freedom are very, very large. Well, that is not the case with this test. So this is actually a t-test of the mean, and it's purely based on the fact that I've got a small sample size. This is a t-test of the mean. I only have 1, 2, 3, 4, 5, 6, 7. N is equal to 7. Which is not big enough to use the z-scores off of my table. So instead I'm going to use the t-scores, which means I need degrees of freedom. Degrees of freedom is n minus 1, so 7 minus 1 equals 6. Whenever your sample size is less than 30, so I'm going to use t-value, and that's because my sample size is less than 30. And they did not give me the population standard deviation. And I don't have sigma. If I had sigma, I'd have the shape of the normal curve. But I don't. I have the sample data, which means I only have the sample standard deviation. So that means I'm forced to use a t-value. And I'll bring my degrees of freedom down here. That was 7 minus 1, which is 6. My significance level was 0.01. Okay, so this goes into table F. Two-tail test. Two-tail test, 0.01. I'm here in the last column. Degrees of freedom 6. So that means I have 3.707 for my critical value. So 3.707. You got that? So 3.707. So my T critical is 3.707. Small sample size, and they did not give me the population's standard deviation, so I cannot use a normal curve. This is actually a t-curve up here. Okay, so I've got my critical t-value, and then step number 3, I need my test value. I'm going to use the calculator, but I'm going to look for a t-test of the mean for the small sample size. Let's see, so I put my data in this one. So I'm going to go to stat, tests, t-test, enter. I don't have pre-computed stats. I have data. So I'm going to go to data, and it says, what's your hypothesized mean? Let me clear what that was. It's 500. My data is not in list 1. It is in L1. It's not in L3. I should say it's in L1. So I want to grab L1. Frequency is 1. Leave that alone unless you're using a frequency list. We're not. And it is a two-tail test, so I leave that. And then I hit calculate. And it gives me my t-scores. Let's see. So 0.57. Let's make sure we type that in correctly again. So stat, tests, t-test. We've got data, 500. L1, 1, that's right, yep, okay, so we got it all there. Calculate, and there it is, negative, so I'm going to be on this side. Oh, you can't see that. So I'm going to be on the left side of the curve. Let me go ahead and set my curve up with all the numbers in it. I have a test t-value of negative 0.57. Let me write that down. You need to write all this down. So your calculator will do this piece for you. You need to have everything else written down to earn credit. So my test value, so this is the t-score for my data, is approximately negative 0.57. I'll call that 0.571. On my t-curve, these cutoffs were at 3. So this is negative 3.7. This is positive 3.7. I landed, this is 0, right, in the middle. I landed right here. I landed in the fail to reject region. Fail to reject. The null hypothesis. So my conclusion, step number 4. fail to reject the null hypothesis. You should always get that one right because it's just right off of your chart. I'm in the middle, so I fail to reject. Step number 5 is your conclusion. Okay, what did it say? It said, is the claim realistic? It is. That 0 t-score was for the 500. Is the claim of 500 rooms realistic? Yeah, we were not that far off. What did we have? Well, we had this average here, which was 461. I'm looking on my calculator, which turned out to not be significantly different. So my conclusion is, yes, the claim is realistic. Did I spell it right? Realistic. Yep, realistic. So again, I found that my sample mean, which is here, 461.9. My sample mean is not significantly different. So I'm not significantly different in the middle. I am significantly different here. We haven't talked about errors in a little bit, so let's do that. I failed to reject. Whenever I fail to reject, that means I have a possible type 2 error. So just note here, we have a possible type 2 error. And you know what? We only surveyed 7 hotels. So, I mean, that's definitely possible. Maybe we weren't in any small towns or we didn't, we only surveyed one area of town or something. So we definitely have a possible type 2 error. And that's where we failed to reject when this was really not true. Maybe the average size is really 1,000, or maybe it's really 22 or something. But we failed to reject when maybe we shouldn't have. That's the possible type 2 error. Let's do one more. So let's do one more t-test. Okay, so on to this one. The average cell phone calls, the average cell phone call length is reported to be 2.27 minutes. A random sample of 20 phone calls showed an average. Okay, so this is, so let's write some things down. So X bar is 2.98. N is 20. Reported to be, the average is reported to be, so mu is 2.27. And a random sample's standard deviation, so we have S is 0.98. Can it be concluded that the average differs? So it looks like another two-tail test. So step 1, well, I already wrote down the null hypothesis. There it is. Mu equals 2.27. Mu does not equal 2.27. Step number 2, let's do the critical value next. Table F. N is less than 30, and no population standard deviation. We only have the samples. So that means that we have to use t-scores. Okay, degrees of freedom. What do we have? 20. So 20 minus 1, which is 19. Alpha was 0.05. Okay, where's table F? Table F. Table F is, so 0.05, 2 tails, right? So 2 tails, 0.05. I need 19. Here it is. 2.093 off of table F. So 0.05, 2 tails, 19, 2.093. So my critical t-value is 2.093. This is a 2-tail test. So if I go ahead and put up my t-scores, there's a rejection region cut off at negative 2.093. And here's my upper tail cut off at positive 2.093. Okay, there's my setup. Fail to reject in the middle. Reject the null hypothesis on the ends. Step number 3. I'm going to put it into the other calculator this time. So let's see, so step number 3, grab my data here. So I go to stat, tests. I need a t-test. I do have computed statistics, so they gave me averages. The hypothesized average was 2.27. 2.98 was my sample mean. Sample standard deviation, it gave me S, is 0.98. If I had sigma, I would be using a z-test. That's why they have S here. N was 20. Not equal. Calculate. Okay, so there it is. They're just confirming a few things, but here's my test value, 3.24. Let me pull that off, 3.24. So test value is the t-score for 2.98. So my test value is about, I should say about, 3.24. Okay, so that test value, 3.24, lives over here. And that was the test value. Remember, that was for the sample mean of 2.98. This is 0 right here, so if I put everything else here, was 2.27. We found the average of 2.98 for the cell phone length of our sample to be significantly more. This is fail to reject. Fail to reject the null hypothesis. And both of these are reject. So either tail, reject the null hypothesis. So that means that we're ready for the decision. I'm in the rejection region. I'm significantly larger than the 2.27 average length. So I reject the null hypothesis. Step number 5, for my conclusion, you really want to go back and answer the question. Can it be concluded that the average differs from the population average? No. No, I'm sorry, yes. Yes, it's significantly different. Yes, the average, no, the average is significantly different. Significantly different from the population. I'm going to write mu because I'm just about out of room. It's significantly different from mu. In the next video, we'll take a look at how to use the p-value.